Welcome to Ask and Learn.
For this problem on the topic of kinetics of particles, we are told that the collar with a mass of 10 kilograms is sliding smoothly on the vertical rod, and at the point where its velocity v1 is 2 meters per second in position A, each spring is stretched 0.1 meters. We want to calculate the final velocity v2 of the collar as it passes point B in the diagram. So if we look at the diagram, we have initial velocity v1 and final velocity v2. We know the force constant of the spring to be 800 Newton meters for each spring, and we know the initial and final stretch of the spring. So from the conservation of energy, we know that the kinetic energy, the gravitational potential energy, and the elastic potential energy need all to be conserved. So delta T plus delta Vg plus delta Ve should equal to 0. And the change in kinetic energy is a half mv squared. That's a half times the mass m times the change in the square of the speed of the block, which is v2 squared minus 2 squared, and we want to solve for v2. And so this is minus the change in gravitational potential energy, which is m times the acceleration due to gravity, 9.81 meters per square second, times the change in vertical position of the collar, 0.3 meters. And this is plus the change in elastic potential energy of the collar due to the force of the spring, which is a half kx squared. And that's plus a half times the force constant of the spring, k, which is 800 newtons per meter, times the change in x squared, which is 0.2 squared minus 0.1 squared. So all of this must equal to 0. So we end up with 5 v2 squared must be equal to 20 plus 29.43 minus 24. And so solving for v2, we get the velocity of the collar as it passes point B, v2, to be 2.26 meters per second.